Okay, so let's look at this. Oh, you know what? I see something wrong in my title here. Okay, suppose a scientist is comparing a population of fruit flies to a population that progresses through its lifespan twice as fast as the original population. In other words, this new population, R, will progress in 1 hour the same amount as the original population does in 2 hours, and in 2 hours it will progress as much as the original population does in 4 hours. Sketch a graph of this population. Okay, so let's think about this a little bit. We're back to our fruit flies here. So P of T. All right, what's happening is the population, that's P of T, is based on time. So much time is going by. And now they're saying, all right, this population that we're studying, the population is growing twice as fast. Or not necessarily growing, but its amount is twice as fast. The span is twice as fast. Okay, so instead of happening at 3 hours, this population right here at 3 hours, it's only taking an hour and a half. So it's going to move it over here. Now what does this first point mean, 0, 1? That's the starting point. Okay, that says this is the population to begin with. That's not changing. But then as time goes by, it's taking only half as long to get the same population. So when we have a point here at after 6 hours, I'm assuming it's hours, yeah, 6 hours, that's happening at 3 hours, so it's in here. And at 7 hours, that's happening at 3.5 hours. So then my graph looks like this. Kind of a curve there, sorry. Okay, and so this is a compression. So back up here on the title, I should have put horizontal compression. Sorry about that. And now, if we wanted an equation, the equation would be based on P of T. But what we would say then, I need a name for this, we'll call it Q, Q of T. Then Q of T would be equal to the population based on half the amount of time, 1/2 T. So maybe that's starting to make a little bit more sense why it's compressing, hopefully. I think they just asked for the graph on this, but if you wanted to write the relationship, there it is right there. Okay.